right, so today we're looking at patterns and functions. Again, grade 8, all of these concepts we have done before. So if at any point you are feeling confused, you need to go and rewatch the videos which are on the website, which is on YouTube, which is on the app. You need to go and spend some time watching the videos so that you can catch up and so that you can understand what's going on. So in our patterns and functions lessons or course, we spoke a lot about different ways to represent relationships. Excuse me. Basically, when we are looking at number patterns and when we're looking at graphs, those are the two main ways that we can represent relationships between an X or an input and an output value, which is usually Y. And so we need to be comfortable with flow diagrams, tables, and using formula to represent these relationships. As you move up in maths, the flow diagrams sort of fall away, but tables, working with formulas, working with graphs, so drawing graphs, can be really, really important for you to be able to do. So this is the foundation of all the stuff that you're eventually going to do in maths up until matric. Even if you plan on doing maths lit, you do patterns, relationships, and graphs in maths lit. So this is going to be a part of your life whether you do maths or maths lit. And so again, it's a foundational concept. We need to know it. All right, so hopefully what we remember from our flow diagrams, if we were here, or rather if you were here with us for that course, is that a flow diagram illustrates to us the relationship or the operations being performed on our input and our output values. So remember, a flow diagram is sort of like a number machine. What happens is we put values into our machine. This is why these are called input values. We do a whole bunch of stuff to those input values, and we end up with an output. Now, the output we represent with the variable y, and this is why when we start to write down formulas, we use x and y. Oh, guys, I'm sorry. Alrighty, so if we start with our flow diagram, when we just start with the first input number, our first input number is a -1. This gets put into our machine, and we now need to follow the operations. Who knows what that was? So -1 times 2. We know that a negative times a negative is a positive. No, it's not, because I'm talking nonsense. It is a positive, but just we're not times a negative and a negative. So let me try that again. A negative times a positive is a negative, and 1 times 2 is 2. Then we need to take that -2 and we want to add 1 to it. Now you need to think about your number line here. And again, guys, if you're not comfortable with this stuff, you need to go back to our integers course way back at the beginning of the year, and you need to go and practice that. So here we are at -2. We want to add 1, so we move up our number line and we get a -1. So we get an output value here of -1. It just so happens that my input is the same as the output. It doesn't mean that that's going to be the same for all of them. But in this case, we get an output value of -1. And this is all from putting my input through our number machine, performing the operations, and getting our output. So what I want from you guys is I want these remaining 3 answers. I'm going to label them A, B, and C. Actually, I just want A and B for now. We'll chat about C. So I want you guys to find the output values for me when your input value is 0 and when your input value is 3. Put those answers for me on the chat. Number them A and B, and we'll see what we get. Okay, so guys, number them like Wanda Celia's done there. A and B. Remember, A is our input of 0 and B is an input of 3. Salabot, well done. Keep those answers coming. And remember, guys, like Yolanda always tells you, you're doing this on a piece of paper. And then when we go through the answers, you are checking or marking. There should be no waiting for me to do the answers for you. Good, grade 8s. Keep those answers coming. I'm going to give you another minute or so. Some of you are even trying the last one, which is absolutely fine. I didn't ask for the last one with an input of X, but you can try it if you want. Good, guys. Okay, so who would like to raise their hand to give me the output value when our input is 0? Oops, Kelsey?
Hello, ma'am.
Hi.
Ma'am, so 0 times 2 equals 0, and then plus 1 equals 1.
Excellent. So guys, really importantly there, whenever we times a value by 0, we're getting 0, as Kelsey said. So 0 times 2 is 0, and then we add our 1. So we need to be very careful when multiplying with that 0. Thank you, Kelsey. Well done. Wandisile, do you want to give us the next one?
Morning, ma'am. Afternoon, ma'am.
Hi.
3 times 2 is 6 plus 1 equals 7.
Excellent. Well done. So guys, there our output is 7. Importantly, you're timesing a positive by a positive. So that's why Wandisile's got positive 6 as the product. And then we add 1, which gives us 7. Well done. Very nice. Okay, so guys, we have to be able to perform these operations. If we're not being able to do that, we are going to struggle when working with relationships. But now let's have a look at this very last situation that we have going here. So here we've got X, and it's going into our number machine. If we say X times 2, whoopsie daisies, we know that we end up with a product of 2X. If we then say 2X plus 1, well, those aren't like terms, so I can't do anything with it. So it means that my output value is just 2X plus 1. And quite a few of you said that on the chat. So very nicely done if you tried it. But what this essentially is, guys, is a formula for this flow diagram. Okay, this is giving me a general rule that we can use to find any output or any input when we are giving or given rather a value. General. I can't remember what I said. I think I said general rule. So basically what this allows us to do is we can now find any input. Let's actually start any output for a given input. I'll explain what this means now if it isn't making sense. And we can find any input for a given output. Okay, I'm going to explain this. I just want to get all my words out. Right, so basically what this means is you can find any input value or any output value as long as I give you some information. What we have essentially done here, grade 8s, is we have found a rule. So this is saying that the output value Y can be found by taking 2 times the input, so times X plus 1. This is what we call the formula or the general rule. Okay. Now that I have that, like I said, I can determine either X or Y, it doesn't matter. So I could now ask you a sub-question or a question leading on from this that says something along the lines of determine the output value when the input, actually let's shorten this, when X is equal to, we can make it anything. Let's say X is equal to 16. All right, so now I could ask you the sub-question. Because we've got our rule, because we know that Y is equal to 2X plus 1, and because we know X is the input, we can use substitution because what I've given you is an X value. So we can now go and solve for our y value. I just want to move this all down because obviously I haven't left myself enough space. I don't like to leave myself space. Alrighty, so if we now go and work this out, we've got our rule. I'm telling you that x is equal to 16. So where I see an x in my rule, I'm going to substitute it in. So y is equal to 2 times 16 plus 1. We know that 2 times 16 is 32 plus 1. And so our output value here is 33. So basically what that's saying is if I go back up to my flow diagram and I put an input of 16, my eventual output is going to be 33. And so again, this is going back to we can now find any output or any input as long as I give you some information to help you. So this would be an example of determining the output. That's exactly what I said. Determine the output. Let me just make my highlighter a touch bigger, otherwise it's going to be chaos. We can also, if we wanted to, determine the input. So if I did B, determine the value of X. Remember, X is your input. If the output is I want to make this too easy. $63. Right, so let's think about what this is saying. So it says determine the value of X. So now we want the input value. That's what X is. If the output, so remember output is Y. Don't know what's happening. We're just going to roll with it apparently. If our output is 63. So this last little statement over here is telling me that Y is equal to 63. That's the value I'm giving you. So again, we can go and we can use our rule that we have worked out to go and determine this. So remember our rule was Y is equal to 2x plus 1. I'm telling you that Y is equal to 63. So now I'm going to take this value of 63 and I'm going to substitute it into my equation. So 63 is equal to 2x plus 1. Now, guys, we haven't done solving equations yet on Watobe or with Watobe. Some of you might have already done it at school, but you should remember solving equations from grade 7. We know that to solve equations, we need to use opposite or inverse operations. So what that means is I'm going to subtract 1 on both sides, because remember my goal is to solve for x. My goal is to get this x variable alone. I want the value of x. That's what I'm finding. So I subtract 1 on both sides. 63 minus 1 is, oh gosh, I'm going up here now, is 62 is equal to 2x. And again, my inverse operations, I want to get x alone. I don't want 2x, I want x. So I use the opposite operation. This is originally 2 times x. So the opposite would be to divide. And I do the same thing on both sides of my equation. 62 divided by 2 is 31. So if we go back up to our flow diagram, what we're saying is if we take an input of 31, we will get an output of 63. Right, so this is why being able to work with flow diagrams, rules, formulas, whatever, is so important. Because once you have a rule, whether it's come from a flow diagram or a table, whatever, you can do a lot with that rule. Now, this comes into number patterns. This idea comes into a whole bunch of different sections, graphs, financial maths, honestly, anything to do with algebra. This idea comes in. And so it's really important that we are able to use formulas that we've been given in order to work out different values. Okay, so I'm going to let you take a screenshot. If anyone has any questions, now's the time to raise your hand and ask. Otherwise, you're taking screenshots. And again, guys, nothing should be new. If you're feeling overwhelmed, remember you go and watch the videos online. We have done all of this before. We're just recapping, refreshing, making sure that we've got the basics solid. Kelsey?
Ma'am, how did you get the when you said y equals 2 bracket 16 plus 1? Ma'am, why did you write y there, not x?
Okay, so because remember, what we were trying to do in that question is we were trying to determine the output. So the output is what I didn't know, so it had to stay y. I knew what the input was, which is why I could replace x with 16.
Oh, okay, thanks, ma'am.
Okay, so guys, that's a really important point. Your unknown, or the thing you're trying to solve for, will stay a letter in your equation until you've solved for it. Okay, so in the other example, question B, x stayed x because that's what I was trying to find the value of. That was my unknown value. Okay. Right, good, grade 8s. Okay, so let's have a look at a situation where we use tables. Okay, now there's a lot that we can do with tables. We can do lots and lots and lots of that, but basically, a table is another way to represent a relationship. So what I've got here, and let's start with A. Let's not run before we can walk. There we go. What I've got here in my tables, I've got a rule. We can see that I've given you the rule y is equal to 2x minus 1. Remember that in your table, you're working with an input x and an output y. And in this case, I'm giving you all of the input values. So I'm telling you what the x values are. So we would need to be able to go and find our output values using a rule. So for example, if we take the first input value of 3, so x is equal to minus 3. I think I said 3, I meant minus 3. Apologies. We have got our rule y is equal to 2x minus 1. And we can now substitute in negative 3 in place of x. So y is equal to 2 times negative 3 minus 1. Now we know 2 times negative 3 is negative 6. And then we need to subtract 1, which we hopefully know is negative 7. So when my input is negative 3 for this specific rule, my output is going to be negative 7. And so again, what we're doing is we're using the rule that we've been given to go and work out different values. So grade 8, what I want from you, 60 seconds. I want the rest of these outputs in my table. I'm just going to number them. So let's say A, let's not say A, 1, 2, 3. I don't know why I've made the choice for Roman numerals. That seems like a weird choice. 1, 2, 3. And remember, guys, when you put these answers in the chat, we need them numbered. So do all of them first, and then put your 8 answers in the chat for me. I've shown you how to do 1. Use the rule, use substitution, and I want those remaining output values.
Let's go, my people. We can do this in style, okay? Once you have all the numbers, right? We want you to actually raise your hand. Once you have all the numbers, you raise your hand. You need to say, number 1, this, number 2, this, until 9. If you get one of them wrong, it means another person needs to raise their hand and say, like, all these numbers correctly, okay? I'm gonna work out quickly what each number is supposed to be, and we're gonna have fun to make it as fun as we can, okay? Because we're doing revision, so
send you a list of the numbers.
I think they're gonna finish before me because I'm looking for a pen.
No, I'll send them to you.
I'm like, where's my pen? I have my book, I'm ready, but I don't have my pen. So let's go, my people. Let's go. Let's see who's the winner of the 2A, right? You need to say to us all these numbers. Teacher Sam was already given to me. So don't give any hints on the chat. Vaisha, if you are done, do you want to say them? Do you want to raise your hand so you can say them out for us? Okay, Bukhali is done. So Bukhali, I'm going to double check you. The rest of us, we are working on it. I know that probably you're not done. Don't worry. When we're done with this game, Teacher Sam can also just touch up on how did we get each, if you'd like, if you are getting confused. But because I know that majority of you have been listening and you understand this work, so we're going to make it fun. Okay, Bukhali, let's go. Let me check on you. Let's see.
Okay, so the first one is I got -5.
Okay.
Then because I
No.
distributed
Sorry, Bukhali. So you just the numbers, all the numbers. So -5, na. I want to see if you get them correctly. Go.
Okay.
You must have written it down. So I want to
Okay.
check if you guys write things down. Let's go.
Okay, -5.
Okay. -5, -3, -1.
Oh, sorry, I
Um,
decided. Yeah.
-3 again.
Bukhali's out, guys. Sorry, Bukhali. You're out of the game. Bukhali, don't feel offended, okay? This is just a game. We're just playing. So we'll definitely get there and we will do corrections with you, okay? Anyone who is done, okay, let's see. Bukhemo, let's see who's going to come to the rescue. Bukhali, you know we love you, right? So don't worry. It's just the way that we play this game. Like this is going to be fun. If we don't do it like this, it's not going to be fun. Bukhe, let's go. Your turn. You start from the beginning.
Yeah, we can hear you.
It's -5, -3, -1, 1, 3, 5, 7, 9, and 11.
Excellent.
Now, game over. Nice, guys. Nice,
Linda has
Bukhe.
all the energy.
Yeah.
Okay, so Butle, while you're with us, what is the pattern?
The pattern is you have to say 2 times the input minus 1.
Good. Okay, so guys, we are following that rule exactly as Butle said. Take your input, substitute it, get your output. And you do the same thing each time. What's interesting though, is what we can see is from our outputs is actually a pattern, a number pattern coming out. If we add 2 each time, we're getting these outputs. -3 plus 2 is -1. -1 plus 2 is 1. 1 plus 2 is 3. And so this pattern actually carries on. And remember, we spoke about the fact that this number, this coefficient to x, is actually telling me in the number pattern, like Siamtanda said there on the chat, what we are adding or subtracting. So that 2 in front of the x is telling me that in the number pattern of my outputs, I am adding 2 each time. All right, so this is why all of these things interlink and sort of go together. This is, yes, a relationship between x and y, but we can translate it or we can put it into a number pattern and we can start to see how these things all relate to each other.
Okay, so before we do anything, Bukhali, I need you back, girl. I need you back. Because Bukhali, you got number 4 wrong, so I need you back so you can explain to us
Number 4.
how do we now do number 4. Yeah, Bukhali got stuck on number 4. So you see, that's how we learn. Sorry, Teacher Sam. Bukhali, where are you? I'm looking for you. I'm searching for you, girl. You know you're my favorite girl. Where are you? Where's Bukhali? Bukhali, raise your hand. There you go, girl. Okay, so I just need you to explain to everyone how would you do number 4, girl, so that we get that answer. How can you do it now that you understand it?
Okay. At first, how I got -1 is because I didn't, look properly, and So, right, we said, we said 1, ne? Sorry guys, my mind today. We said
I understand.
It's okay, you're doing good. You're doing good. Let's go. How would we get the
Okay.
answer?
x equals to 1, right? So we said 2 brackets 1 close brackets minus 1. So if we were going to sorry
That's
guys.
okay. You're doing well.
You're doing
Okay.
well.
So we're gonna say 2 times positive 1 is 2 minus 1 is 1.
Yes,
Good.
go. Yes, Miguel. Thank you so much, Bulale. You see, now you know. Now definitely you know. And I know that it was just a mistake, not because you didn't understand it. Sometimes we do, like, these kind of mistakes. So anyone who has a question for Teacher Sam, now is your time. If you didn't get these numbers, please do make sure that you ask so that we can help you.
And guys, what Botale said there, like, we make these mistakes in a test and exam. We make these really silly mistakes, and it's okay. Like, everyone makes mistakes. I still make really silly mistakes sometimes, and it's just because, like Botale said, sometimes we don't look at things properly. I know sometimes I look at things very quickly and I don't read the question properly, and then I end up doing nonsense. So this is a lesson in reading your questions very carefully and knowing exactly what you're being asked to do.
Yep. Any questions, guys? Musa, is that a question? Ooh, Musa is our new Hey, hey, welcome to Watobe. You can unmute on your side. Let's hear. What do you want to ask? There's a pop-up button that comes on your screen. You just need to click on it so you can be able to communicate with us.
Ma'am.
Yeah.
Yes.
Yes.
So ma'am, for question 1, ma'am, ma'am, it's supposed to be minus 6.
Okay, so just be careful. If we look at the first one, there we are. This would be y is equal to 2 times minus 2 minus 1. So 2 times negative 2 is negative 4. And negative 4 minus 1 is negative 5.
Okay, ma'am. Thank you, ma'am.
Good.
Nice one, Musa. I'm glad you understand. Just give us another challenge. I'm up for it.
I can hear. Okay,
I'm
guys,
relaxed.
so we're going to have a look at this table. I don't want you to get too excited just yet because I'm going to change a couple things because, Yolanda's got us all excited here. So our rule is going to be minus 4x plus 1. And I'm going to add on an extra block here. Beautiful looking block. And just have to do some quick maths now in my head. And our output. Right, so again, I want all of the missing values. I'm going to put letters here. So 1, 2, letters, numbers.
Let's go, my people. Tuto, I saw you. You are ready, Mugai. Start working out. You already know these numbers. Start working it out. Let's go, guys. We're looking at the formula negative 4x plus 1. Y equals to negative 4x plus 1. You need to give me numbers 1 until 11. When you have those numbers, you need to raise your hand up, and then we can do that again. Ubakeng Mugel, wake up. Oh, wake up. You're going to make me sleepy also. Wake up off that bed. I'm also cold. But I'm trying my best by talking a lot. Wake up. So I need an answer from Obakeng. Obakeng, I need your answers. Let's go. Let's go, guys. We all are cheering up for Ubakeng. Ubakeng is going to put the answers on the chat. But any one of you who wants to, Ubakeng is not a girl.
I mean, Yolanda says my girl for anyone. It's not like she's assuming anything. Yolanda's just our cheerleader.
I apologize. Yes, I'm so sorry. I apologize. Look, I didn't mean it. It's because I didn't see your face proper. I really didn't. Sorry. My bad. But it's true. I say Mughal to everyone.
Yeah.
I'm gonna start saying Mubai. You see, it doesn't sound good.
No, exactly.
It really doesn't. Okay. So
Yo,
Bageng, please
Shadi,
do.
you're on it, babes. Jeez, Louise. Okay.
Okay, anyone who is done, you can raise your, okay, I'm not even done myself because Teacher Sam hasn't hooked me up with answers. I can't even compare the answers. So let's go, my people, we can do this. We can clearly do this. Remember, do it on your book, okay, guys? Do it on your book, and when you are done doing it on your book, you can either raise your hand or put it on the chat. I have no problem.
And
Okay.
guys, don't forget, I've put this 11 up here. So it's a little bit different, but it's there.
So those of you who are giving me answers one by one on the chat, it means you're not listening. You're not listening to the question. You're not listening, guys. We're trying to make it fun. Okay, Ntsaki, so let's go, Mugal. You are ready for us? I hope, yes, you are. No, you're not. Oh, well, it's Mugal with everybody.
You ready?
Yes.
Yay.
Guys,
Number
girls
one.
are winning, by the way.
Number one is -11.
I think we got.
Sorry. Okay, so let's just do number one, guys, just that we're all on the, I don't know what's happening. We're just going to roll with it. So here, y is equal to -4 times -3 plus 1. Yes. A negative times a negative is a positive, and 4 times 3 is 12. So this would be 12 plus 1, which gives us 13.
Okay, so Ntsaki, so you need to go back and then recheck all your numbers, Mugal. But thank you so much. I'll call you for corrections once you understand how we get things. I'm sure you also just made a little bit of a mistake. So who was here? Who? Oh, I saw someone's hand. Someone new. Nokutenda, let's go. You are ready with those numbers for me? Give it to me, Nokutenda.
Okay,
Let's go.
so number 2 is 9.
Uh-huh.
Number 3 is 5.
Uh-huh.
Number 4 is 1.
Uh-huh.
Number 5 is -3.
Yes, go.
Number 6 is -7.
Yes.
Then wait, did I skip? Okay, number 7 is -11.
Good.
Yes.
Number 8 is -15.
Yes,
Good.
go.
Number 10 is number 9 is -19.
Yes.
Number 10 is -23.
Yes.
Yeah. Then
Number 11. Don't cheat.
number 11 is -27.
Oh, so close.
No. Okay, no pretend that. Let's listen to corrections. Okay, but well done,
Okay.
girl. Let's see who's going to help us. Sinyane. Woo, I haven't heard of this name. Sinyane, are you new or is just your first time participating? You see a pop-up on your screen, Sinyane.
Oh, yeah.
Hello.
Hi. Is it your first time on Watobe?
No.
Oh, it means you haven't been participating. I'm gonna call up from your name every single time. Go. You've been cheating. What's number 11?
Number
Go. Let's go.
11 is positive 28.
Well done.
And do you want to do correction on that one?
Yeah, can you explain to us how we got that?
Yes, please.
Okay, so -4 times 28 is -12 and is -112, and -112 plus 1 is -111.
Good.
Nice. Is there anyone who has a different explanation to this one? So Teacher Sam gave us -111. We're trying to find 28. Who can raise their hand to explain in that matter? How can we find the 28? Who got it? I know that Sinyana explained and we did get the minus 111, but we are looking, oh, Vaishya is here. Let's hear you out, Vaishya. Teach us.
Can you hear me?
Yes.
So I said negative 111 minus 1, which gave me negative 112, and negative 112 divided by negative 4, which gave me 28.
Oh, that's smart, but that was so fast. Maybe teacher Sam will have to break it down for us. Thank you, Vaishya. That was really
Okay.
nice.
So guys, so what Vashali just said there is using the rule. So y is equal to minus 4x plus 1. If we substitute in what we know, remember this, negative 111 is y. So it'd be negative 111 is equal to minus 4x plus 1. So our inverse operations tell us to subtract 1 on either side. Hence, we've got the minus 1 there. And then once we've done that, we would have, I'm just going to write it on the side here, we would have negative 112 is equal to negative 4x. Again, our inverse operations would tell us that we need to divide both sides by negative 4x. Oh, I don't know what on earth that was. By negative 4 rather. And that's what we're doing over there. So using those inverse operations, like we said in the last example, we're able to find out any input value as long as you've got the output value. But very, very nicely done, grade 8. Very, very nice. I'm going to leave that there if you want to take a screenshot. If you have questions, please raise your hand and ask.
I don't remember the person who said the answers first. Who was it? If you know that you were saying the answers first, the first person who gave us the first answers at the beginning. Sorry, I'm very bad with names, guys. You guys must be patient with me. If I remember you, please raise your hand. I just would like to understand if you did get the explanation that teacher Sam just did now. And we are good to go. If you can just give us thumbs up, then we'll be good to go. Okay, I saw some thumbs up.
So since well, I would use the inverse operation personally. That's the way I would do it. The reason I would definitely recommend it is because as you go on in maths, being able to do inverse operations is so important. So if you can start practicing it now, it's just going to make your life easier later on down the line. So I would use it personally. It's not the only way to do it, but it is going to help you later on in life.
Okay, we are sorted. I'm just not sure whether Tuto is talking to us. Okay, I'm gonna skip that. Tuto, I guess you're not talking to us, right? Yes, I am talking to you because I'm watching you. So whatever that you do, I see. You were doing something there. I'm not sure whether it was a communication to us or not, but I saw all of it.
I'm assuming from the reaction it was not for us.
Exactly. Definitely it was not for us because that was just, yeah, we love it. That was some exercise that we were supposed to do, all of us. Mosa, do you have a question? I'm gonna unmute you. You can just ask your question before we move on.
So, ma'am, this question, ma'am, number 5, ma'am. Ma'am, could you please explain it to me, ma'am?
So number 5, this one over here.
Yes, ma'am.
Okay. So guys, if we look at that situation over there, I'm just going to get a better color going on here. And we're looking at the answer for number 5. If we take our rule, we've got y is equal to minus 4x plus 1. And we know that x is equal to 1. So we substitute. Minus 4 times positive 1 plus 1. A negative times a positive is a negative. So we've got minus 4 plus 1. And minus 4 plus 1 takes us to that negative 3. So it's through our substitution substitution, we're getting -3. Does that make more sense?
Yes, ma'am. Thank you, ma'am.
Good. So guys, just on this, while we spoke about the pattern in the last question, this too has a pattern. What we see is that each time we're subtracting 4 to get from one output value to the next. And that's exactly what my rule tells me, because the coefficient is -4. That is how we see the pattern of subtracting 4. Andile, when you say question 1, I did do question 1 with you. So here question 1's working out is -4 times -3, a negative times a negative is +12, and then +1 gave us the 13. Right, so I did do it. The working out is there. Righty, guys, I think we've got time for about one more. You guys have done really nicely. No problem. So I'm just doing a bit of a skip here. If we have a look at question 4, all I've given you is a list of numbers. So my first question to you is, and I just want you to put it in the chat, is there a pattern? And if there is, what is the pattern? So what is the pattern of these numbers that I've listed here? Good, grade 8. So what we see is that to get from one term to the next in my pattern, I'm adding 5. So 2 plus 5 gives me 7. 7 plus 5 gives me 12. 12 plus 5, 17. So now we've got a pattern. So the first thing I would like from you guys is in the chat, I want you to write down the next 3 terms. So what are the next 3 terms to this pattern if we carry it on? Try and do them all together. Oh, sorry. So when I say all together, try and give me your answer like Mbali's put there. Good, guys. So we know we just keep adding 5. 17 plus 5 is 22. Plus 5 is 27. Plus 5 is 32. So we can very easily get our next pattern. What we need to be able to do from this is we need to be able to write down a general rule or a general formula. Okay, we're getting there very slowly but surely for this pattern. Okay, so if we go back, the general rule is this thing that we've got here, y equals something. So we need to put our rule in the format y equals and then apply our rule. Now remember what I've been saying so far is that that coefficient to x in our rule is always the number we're adding or subtracting. So I'm going to start by saying that automatically I know I've got y is equal to 5x. That isn't my whole rule. I'm definitely not done, but it's a start because remember, this coefficient to x, the number in front of x, is what I'm adding or subtracting each time. But now I need to make sure my rule actually works. So this is where we just double check whatever it is that we're currently doing. So if I go and have a look at my pattern, remember this is the first term, second term, third term, fourth term, and those would be my input values. These are my output values. If I go and double check and say, okay, if x is equal to 1, and I use my rule that I currently have 5x, 5 times 1 gives me 5. But that's not my output. My output, as we can clearly see in the list of numbers, is 2. So the question is, how do I go from 5 to 2? What do I add or subtract? Well, I know if I subtract 3, I will end up with the output that I want of 2. So to my rule, I add a subtraction of 3. So my general rule is y is equal to 5x minus 3. I can go and double check myself. If I feel like my maths is a bit dodgy, I can just go double check. So if we go to the next one, x equals 2, we want an output of 7. So y is equal to 5 times 2 minus 3. 5 times 2 is 10, and 10 minus 3 is 7. That's what we wanted. So once we've got our rule, we just double check ourselves, make sure that we're on the right track. But remember, a rule is not something that should be scary or hard to deal with. Once you know what your pattern is, you build your rule from there. Alrighty, guys, and that's basically everything we sort of need to know about patterns and relationships. So again, take your screenshots. If you have questions, now's the time to raise your hand, but you're going to see, as Yolanda told you at the beginning of the lesson, that a poll is going to pop up. Please make sure you do answer it. Simtanda?
Good afternoon, ma'am.
Good afternoon.
Ma'am, yes, ma'am. My question over here, at school, we do it in a different way. We say TN, we don't say 5x, we just say TN.
That's absolutely fine. So we did speak about TN. So here you would have TN is equal to 5n minus 3. That's absolutely fine. It says exactly the same thing, and you're welcome to use TN. Yeah.
Okay, thank you, ma'am. Have a nice day, ma'am.
You too. Okay, so guys, what Simtanda, you can just ignore me. I'm clicking things. So what Simtanda said, there's some people have learned it with TN. We have spoken about TN in our course on patterns. So you can use TN, but this is more just to remind you of how to find a rule. Because if you know how to find a rule using X and Y or using TN, doesn't really matter. It's just changing things. So what you can see here in what I've done, is you can see that the TN means exactly the same thing as Y, and the N means exactly the same thing as X. So you just swap them out. So it's not a problem either way. Matale?
Man, can you hear me?
Yes.
Okay. So, ma'am, like CM Tanya said, ma'am, like, can you like use TN? But like, ma'am, in my question, like, does it always have to be TN, or can you like also use N?
So it always has to be TN equals, because TN represents Y. And because we use Y equals our rule, it should be TN equals. So I hope that helps.